We are live. My name is Sébastien Couture, and this is The Interop. This is a show where we dive deep into the decentralized economic networks that make up the interchain. I'm here today with Fabian Riewe, who is the CEO and co-founder of KYVE. KYVE is a decentralized data lake protocol. We're going to get into all of that and understand what it means, how it integrates with the Cosmos ecosystem and beyond. And also, we're going to dive deep into Arweave. Hi, Fabian. Thanks for joining me.
Well, thanks for having me. We have quite some agenda for the day, I see.
Yeah, it's going to be interesting because Arweave is something that I kind of, passively pay attention to. I've got lots of friends who are like just all about Arweave. We've also have some content here on the show before about Arweave, but yeah, I'm still like struggling to understand how it all fits into Cosmos. I think you guys are probably the project that, are in the Cosmos, but are also like mostly close to Arweave. Before we get started, though, if you like the videos that we're producing, if you like this content, please make sure to subscribe, hit the like button, hit the notification bell, because we usually do live streams every Thursday around this time. So yeah, tell me a bit about your background and how you came to be working on KYVE.
Absolutely. It's a very organic story, so to say. So I'm a software developer, and I was just working as a freelancer, and then got invited by the SAP, which is a big German development company. I think it's pretty international, actually. I don't know. But so they invited me over for a hackathon. And this was the first time I was in contact with crypto. Like some dude introduced me there. I don't know how he got into crypto, but that's that. And we said, you know what, for this hackathon, let's build our own ERC20 token. This was like 2019. Yeah, 2019. We're like, okay, cool. 2 hours later, we had an ERC20 token. We're like, okay, it's a 3-day hackathon. What are we going to do with it now, right? Like, okay. And so we looked a bit deeper into all the crypto stuff, but we couldn't really see use case and so on. And then I was chatting to the guy next to me, and he was an SAP intern, and he was working on the CLA assistant. And the CLA assistant is an open source tool from the SAP used by like Amazon, PayPal, big enterprises that they have the problem that when they have external developers doing contributions to their open source code, that they have to then sign online an agreement, a contributor license agreement, CLA, that says that basically they're given away the rights on the code that they are contributing to the project. And they were actually storing those signatures on like some small hard drive sitting on the fridge in like the office department, because it was like a work in progress tool for them. I hope it's fixed by now, but I guess this was what the dude was working on. Then I got back to the hotel and I was thinking about, actually, that's a perfect use case for blockchain, right? Like if I would store like the proof of signature there, then no one could ever say, oh, actually, no, I have never signed the CLA, because it's all very happened on GitHub, right? I don't think it had any big legal substance, so to say. So I thought there might be a cool like use case. And then the other 2 days of the hackathon, I developed that and always thought, well, nice proof of concept. It was deployed to, well, Ethereum testnet. Even back then, gas was already expensive. And then, yeah, that was my crypto journey. And then half a year later, the dude from the SAP hit me up and said, hey, have a look at Arweave. It might be super cool for your signature use case. Basically, you can build a decentralized DocuSign. I was like, oh, actually, that's very cool, because now what Arweave allows me compared to other blockchains is that I can upload much larger files. So I could actually, attach the real contract and then let this one basically be signed by my party or my counterparty or whatever. So that's nice. So I reached out to Sam, the CEO of Arweave, to maybe just chat about him, what he thinks about it, and so on. And then we actually both kind of got torn into this rabbit hole of actually like, how do we even know if an address is a real human? How do we even know if my counterparty is legit? Because it's very cryptic, right? It's not very user-friendly. We're like, okay, that's interesting. And then this was my first ever like big crypto project. It's called Verify. It's fully based on Arweave. And basically we are analyzing the Arweave traffic. And by this, are able to compute a score for an address saying if it's most likely human or not. So think about it a bit like on-chain KYC, but it's not through an external like KYC provider. And then this happened. This was then late 2020, very early 2021. And I was reaching out on the Discord. It was a community project. Hey, does someone want to help me build this? And then John, who's now the co-founder of KYVE, reached out to me and said, hey, actually, yeah, I can help you. I would love to work on this. I was like, awesome, that's great. So I met him on Discord, and then we started working on Verify, launched it in December, and actually quite some good revenue on it. It was like a little tipping system, and this worked out super nicely. And then we were just browsing through Gitcoin one day and saw a bounty from Parity, that's the development company right behind Polkadot, and Arweave, and it was a shared bounty about bridging Polkadot data to Arweave. 7.5K or something. We're like, oh, that's easy weekend money. Let's do it. So we did it, and I got some amazing feedback for it. And then we're like, oh, actually, that's quite a system that we can scale now, right? This archiving kind of solution. I can go much deeper into it maybe later, why this is such a cool thing. And then from there on, like KYVE was born, right? Like we started integrating more and more chains. The team got bigger and bigger. I think now we're around 16 to 20 people now switched over to Cosmos and everything. Happy to talk about this more in a minute. And yeah, well, now I'm here, I would say. This is how the whole KYVE thing happened and my backstory.
Cool. And how long ago did you start working on KYVE, and sort of what's been the arc of, the project? Like, I don't think you guys are live yet. You have an incentivized testnet, but you're going to be live like shortly.
Yeah, exactly. So maybe let me just now step back and talk a bit about what KYVE actually is. So with KYVE, we are building a fully decentralized data lake. And this means basically that we are getting data from literally any data source, blockchains, off-chain data, financial data, whatever, into this data lake, and then make this data accessible for developers. Right? Think about it as like an oracle on steroids. So it's a little oracle for any type of data. Validating it, it's sure it's correct. And this idea fully started out on Arweave and working with Arweave smart contracts. So they were pretty new back then and weren't production ready to the extent that we needed them. We needed like contract to contract calls that wasn't supported, and so on. And in general, like just Solidity was more of a standard that we needed to work and to scale with. And so we switched away from using a full-on Arweave stack to a Solidity contract Arweave storage stack. So we're storing, and we still do, by the way, store all the data on Arweave, and all the logic is handled by, or was handled by a smart contract. Then we realized, actually also EVM also doesn't give us the flexibility from a tech perspective, well, because you always have to share your transactions, like the transaction space with other projects, right? It was bull market, so gas prices went up the roof, and we're like, oh no, this is not what we want. We want something where we have our own space, and we are sure that like KYVE in itself stays economical. And this is when we looked at this was February 2022, so 8 months ago. We were like, okay, should we now switch to Cosmos or to Polkadot? And us personally, we weren't big fans of the Polkadot like shared security system. And we thought, well, if we're going to build something that's independent, we want to have something truly independent, right? And this is then how we decided to go with Cosmos. And no one on the team know neither Rust or Go. So this was a pure decision of kind of like the philosophy behind it. And this is, how that went. And then I think in April or something, we then released that we switched to Cosmos, deployed that, had the incentivized testnet going on now for quite a while, 40,000 participants, absolutely insane. And then now really just, going towards mainnet in big steps, and really very excited for it. And I really cannot wait to launch it. That's, I would say, the current status quo.
Cool. Well, I'd like to talk about permanent storage. Because I think it's one of the most interesting use cases in crypto. So, on Epicenter, we've interviewed like tons of projects over the years that wanted to do either decentralized storage or permanent storage. And I've always felt like this was the thing that got me kind of really excited about crypto in terms of non-DeFi use cases. And, I was really impressed by projects like Saya, even back in the day, like storage, these projects. But then Arweave came along, and they had this totally new model and this new kind of proposition of not just decentralized storage but permanent storage. I have yet to really have confidence, I think, in the tokenomics, or fully understands the tokenomics to be able to have confidence in the fact that like this storage is actually permanent. So I have friends who just kind of are big Arweave fans and think it's super cool, but I'd like you to maybe explain, in your view, like what about Arweave makes it so interesting, and how does it ensure its permanence? Because when you say permanence, like that you're talking in absolute terms here. You're really talking about like something that will exist forever. There's it's not a binary thing, or it is a binary thing. It exists forever or it doesn't, and like to have absolute certainty about this permanence is like a big statement. So how do you describe how it works, and then also the tokenomics that make sure that the storage remains permanent?
Sure. I'm happy to break it down, because that's actually also like a big reason why KYVE exists, right? And I think also gives like a good baseline on like how KYVE really works. Basically, the problem you have right now on blockchains, like on the traditional ones, right, Ethereum, Solana, and so on, is that the pure incentive, the token incentive, is set on block production, right? And this means, of course, that you only get rewards for actually creating blocks, but not for keeping the data. And this is what's now happening, for example, to Solana is a famous example where a lot of nodes are pruning their data, meaning that they're leading it out of the database, just because it's more flexible. And of course, you maximize your profit by investing, the least in the incentive to not store any data, because they're really not incentivized to do that. And then Arweave has the complete opposite. So Arweave is highly incentivized on data access and data accessibility, so to say, or data permanency. I really don't know what the correct term for that is, but basically the way they have designed the tokenomics is basically by saying, listen, we're going to give you tokens for the exchange of data, right? And the more rare data is, the more tokens you're going to get for discovering that and keeping this in your network, which is a very smart approach, right? And then they also say, listen, we're not a blockchain where every node has to have a full history. We're a block weave, thus the name, right? Arweave, where actually one node can have as little data as it wants, but of course maximizes its profit by having all of the weave, like all of the data, right? Because then they can always retrieve any data, meaning that they get the most rewards for that. And I think if you understand this concept, then it makes more sense why you would say, okay, this is why it's permanent storage and more of a block weave and then a blockchain. And the reason why it's permanent, that's then a more like in-depth design choice of Arweave. And actually, I'm a big fan of also challenging Arweave for permanent storage a bit and actually saying there is no need for every piece of data to be stored permanently, right? Accounting data is a very good example. I think 10 years in Germany, at least where I'm from, by law, it is mandatory. And then after that, you can absolutely discard it, because why wasting like money basically on something that where you don't need to pay for? And then Arweave has the easy thing, just says, listen, you're just going to pay for 200 years of storage in advance, right? And they have the storage paradigm where they say, okay, the cost of storage is decreasing by, I think it's 30% every year, right? And of course, by this, you can just draft a mathematical curve, right? And then you can follow this. You can compute how much you would have to pay for storage now in order to ensure that the node always has enough money to pay it for at least 200 years. That's how they justify the permanency.
Yeah, with regards to the tokenomics, then, so the idea is that you're incentivized as a node to store data that exists in scarce amounts in the network. So if there's like data that is on Arweave that is not replicated to some factor, there's going to be an incentive for you to pick up that data and replicate it on your node. The thing I think that with Arweave that I've always had a hard time kind of grasping and coping with is this idea that you mentioned, that like all data should be stored forever. And as far as I understand it, or at least when I was, when we interviewed Sam on Epicenter, I think like a year and a half or 2 years ago, there wasn't a way on Arweave to effectively delete information. Like all information on Arweave was to remain permanent forever. Is that still the case? And how then you deal with this idea that like not everything needs to be stored forever? Because like if you go to some extreme, like you can go to extreme, like very granular kind of data storage policies for any sort of application, right? And you can like store every single finite piece of transitional information in state change, and then you just have like an infinitely large data set.
Yeah, exactly. So actually, I don't think there is a way on Arweave to ensure it's not permanent, right? I think that's actually something where other storage solutions kind of might have their unique selling point, right? And I think it's a big question of which one's actually winning over the other, right? And also, like, I mean, for KYVE, actually, we are storage backend agnostic, is what we like to say, meaning that it is possible for those storage pools that are like relaying the data, they can relay it to other backends. So they don't have to use Arweave. They can use like Falcon IPFS, Makina or Near or whatever, right? We just as a team, I mean, because we came out of Arweave, right? That's our biggest expertise, and so of course we are staying on there and pushing that. But we do absolutely see like a valuable point that it's not worth it for every piece of data to be stored permanently, right? And also there comes also a lot of responsibility from an ethical point of view for storing data permanently, right? Because what might be okay now might not be okay in 50 years, 100 years, 200 years, who knows, right? Permanent means a lot, like, right?
And coming from Germany, like, you're well aware of like this whole right to be forgotten, regulation that I think was targeting Google, several years ago, and is still very much in the say German mindset, right? That like no information should be permanent. A lot of people still pay in cash in Germany, and for for reasons that are very cultural, and so there is I think also like cultural ramifications to this. Okay, so Arweave still stores everything in forever.
Yes, exactly. So I know there is, I don't know if it is in place by now, but I know that in theory nodes can agree on not storing any transactions anymore. So let's say you upload some illegal files to Arweave, right? The nodes could agree on excluding these transactions from the data exchange, and then over time, the data would extinct there. But then my big like thesis on this is if it's illegal data, it's usually always has some high value attached to it, right? Then there might be a subnet of Arweave or a sub fork of Arweave or something where they just don't use this blacklist, right? So you would keep this data around. It would be much rarer to find, but actually then you could write algorithms to find it. Like
you could also encrypt the data.
Yeah, right. Well, encrypted data is this one big problem in general, right? Like if it's encrypted, whatever, you cannot do anything against it, right? But if it would be open data, then I would guess even then like something would in that region would form, right? So it's questionable on how this works.
Yeah. How does Arweave deal with spam then? Because like, I mean, I guess you also have to pay to post data on Arweave, but like if you had some, like, I don't know what the capacity of Arweave is currently, but let's say you had like some state actor that just wanted to spam Arweave for whatever reason, and had, unlimited money. I mean, this is the same, I think, with like, Bitcoin or any other sort of, like
but
decentralized network that has some amount of scaling issues. You could just spam Arweave and just post like tons and tons of data to it, making it practically unusable and maybe even economically unfeasible over time.
Yeah, and I can tell you, it was us. It was KYVE in the early days that did this. Like KYVE, like we outscaled Arweave at one day. And I remember I remember a message from Sam. We were in development. KYVE text like, "Hey guys, I think you guys just killed our gateway," and we're like, "Oh, okay." And so we're like, "Okay, no worries." And then basically, so they did some optimization, of course, right? We did some optimization as well, and then Bundler came along. Bundler came along in the NFT hype from Josh. We are very close with him. And what Bundler is, I'm happy to give a quick TLDR. It's basically like a scaling service for Arweave. So what they do is they take all your data, but with foreign data. Like basically, it's like a roll-up for Arweave. They take all the data from others, and they just ensure you that at one point in time it's settled on Arweave. And this really takes off some load, and now they're driving actually 95%, I think, of Arweave's traffic.
Wow.
Which is crazy. And on the KYVE side, we've dealt with this by also bundling the data custom, like basically on our side. So we're pushing much less data to Arweave than we did in the early days. Especially the NFT, I really took down Arweave for a while. But it was never a network. It was always the gateway, as far as I'm aware, which is the indexing service on top of Arweave. And this was the one that, didn't like all that traffic, as far as I'm aware.
So before we get into KYVE, I do want to talk about Arweave smart contracts briefly.
Yes.
Like, how does that work, and how is it different from, say, the paradigm of smart contracts that we're used to with Ethereum, or like Cosmovisor, like these kind of on-chain state transition contracts?
I don't know. I must openly admit now, I don't think I ever did, that I'm not a big fan of the Arweave smart contracts. Because of the way the Arweave smart contracts are designed, It's called client-side execution, right? Which means that you have the transaction happening, like I'm transferring, right, 10 tokens to you, you're transferring 10 tokens to me. And then usually in a normal network, like a normal network on Ethereum, right? For example, the nodes, they would do the updating state calculation, right? And always store in the latest state, so it's fast and easy to access. And you find consensus about it, right? While, and this is now the big problem on Arweave, your client does it, meaning that client is, well, your computer, right? So your computer actually has to download all of the transactions that have happened. And for 10 transactions, it's no problem, but for 1 million or 1 billion, it gets quite exhaustive, right? And then you have to compute it basically to the latest state, which also takes some time. And computation always takes some time, and even the fast implementation would slow it down for an indefinitely large, right, number of transactions. And that's actually one of the reasons why we switched away from it. And the other reason being that there is no consensus on a state. So if my client might be corrupted, or I might not read some data, and I end up with, I don't know, I have 100 tokens, but on your side it says 101 tokens, who's correct? Right? We don't know.
Yeah.
Right?
I mean, you'd have to go back and, like, someone would have to go back and look at all the state transitions that have been posted to Arweave, and then I guess that would be the source of truth.
Yeah, but it gets even more, funnier, because then, you had different teams developing different clients, and the clients had different ways of interpreting some data, and this really completely demolished the state. So like one story, my favorite story there is actually that we were using the native SmartWeave client, and then the Redstone team was building their client. And basically what happened then is that we were executing the exact same contract with the Redstone client, but it got a completely different result, completely different. We're like, okay, why did this happen? And we investigated, and we found out that very early on, an investor unlock failed on either our or on the other client. And this investor unlock, of course, right, then influenced a weight on the vote on the governance that was changing the parameters of the network. So it's really like this complete chaos after this, right? Because you have different parameters, suddenly you different weight shifts and so on, and it just got worse and worse and worse, right?
Yeah. How do you unbundle that?
Exactly. And then, then the solution from the Redstone team is to build this like Warp. I think they also have the protocol Warp, right? It's like their smart contract network.
Yeah.
But to be honest, it is pretty centralized, if not basically centralized, because they have a caching service, and then it's not trustless anymore, right? Like, how can I trust someone team's cache? That's not like the blockchain spirit and not how it should work, right? And this is actually one of many reasons why we switched away. Another one is also, I think that a lot of people have to keep in mind, is this. It's called foreign call protocol. It was a brainstorming idea by Sam, Tate, and John, our co-founder, which is that, okay, how can we make contract-to-contract calls possible? And because everything is stateless, you have to do this weird concept where basically, if I would like to interact with you, right, I would basically have to hold up a sign on my side saying, hey, if you read this, please execute this on your end. Right? And then you would read this and say, okay, Fabian says I now need to execute this. But then you have two problems. One is the Turing problem. That means that you don't know if I might make you run into an infinite loop, right? And then imagine you're billions of transactions in, and suddenly there's some bug, and I'm able to call, like an exploit, call an infinite loop on your side, and the contract is broken forever. There's no way to fix it, right? It's broken forever, which is super, super dangerous. And that's the reason why ETH introduced gas, right? To solve the Turing problem, because they said, listen, at some amount of computation, we're going to abort it and don't make the transaction count because something is super off here, right? Arweave doesn't have this, and it's a bit of a, they say it's gasless, but actually it's dangerous that it's gasless, in my personal opinion, right? And then the other problem with that is you have an ever-growing state, because me on my side, I don't know when you have read the message you are supposed to read, because it's stateless, right?
Yeah.
So, yeah, I always have like to duplicate myself and create a new Fabian holding up a sign. Hey, next time do this. Hey, next time do this. And this just explodes the state. And now imagine like lots of smart contracts interacting with each other, and you have suddenly no clue what's going on. It's just not scalable at all.
Are you familiar with Urbit at all?
No, what's that?
Well, so yeah, Urbit is this kind of decentralized compute system. I wouldn't know how to describe it. My co-founder at Epicenter is a big fan of it, and basically everybody has kind of like their own computer, right? Like their own kind of virtual machine, and then things settle when you communicate with others in this peer-to-peer network. So I don't know if you're familiar with secure scuttlebutt.
Nope.
No. Okay. Yeah, this is like deep in the weeds kind of stuff. Oh, geez, I need to like stop pressing my chair. Yeah, but yeah, basically it's kind of like this stateless compute thing where there isn't actually a network. There's just like kind of data structures that settle with other data structures.
Okay.
I'm butchering this explanation, but it sounds kind of similar. I need to do a little bit more research about Urbit. But so yeah, what's the interplay and the interaction between, say, like Arweave and the Cosmos ecosystem? And because I think being in the Cosmos ecosystem, I think I don't know of very many projects that are building on Arweave or leveraging Arweave. I know like the Redstone team are doing some stuff with IBC and maybe the Cosmos SDK, but there's not a whole lot of overlap between those two ecosystems, I think. I mean, maybe I'm wrong, but what is the kind of play here, and how can like the Cosmos ecosystem like leverage Arweave to its benefit, do you think?
Yeah, I think we're getting more and more into this like modular tech stack, right? Where you have some technology. It's in our case, right, where the logic. Well, Cosmos is very suited for like token logics and logics in general, so we use this for that. Arweave is very suited for storage, so we use that. And actually, what's very crucial is that the bridge in between is important, and that's basically what KYVE is, right? And for example, I would never recommend actually anyone else immediately integrating with Arweave. If not your whole system is completely trustless, right? Because once you store something on Arweave, because, well, it's there forever, right? You really have to make sure it's actually correct, because there are huge potential, like attack vectors there that are just really like dangerous. And for example, right, because you just mentioned like the Redstone team, right? They're building this Oracle system, and they actually have this system where you can dispute a piece of data after it got uploaded, right? And from my personal point of view, it's not a very elegant solution to a problem, because let's say I'm uploading a financial data stream, euro to USD prices, and some hacker is able to corrupt the incoming stream, right? Then my application who's using the data is already using this incorrect data. And then later on, after I might have the damage, can then say, yeah, I raise a dispute, this is incorrect. But actually, there's nothing reimbursing me actually that there has been some incorrect data being uploaded, because it's like from one central, right now at least, right, from one central provider being uploaded. And that's something we do different with KYVE, where we say, listen, we are actually uploading and validating the data, and after it has been found valid, just then the KYVE chain publishes the proof and says, listen developers, listen apps, whatever, we know that this Arweave transaction ID has some absolute correct data that you can use in your application safely, right?
So could you leverage KYVE to build like a rollup, for example, that like in the same way that Celestia is a data availability layer for rollups? I think the Redstone team was doing something kind of similar, where they're leveraging Arweave as a sort of data availability layer. Is this also what one can do with KYVE? Yeah.
Yes, actually. So the KYVE really possibilities on that side are kind of endless, because I like to say what's KYVE is a big of a triangle, right? And like we're really focusing on getting Web 2, Web 3 data into Web 3, right? And then you can do whatever you want. After the data is there, you can do whatever you want. So you can use it for example, I just see the little region ticker down there, right? It's like they have a lot of off-chain data they are working with, and they have reached out to us and said, hey guys, how can we get this data on-chain? How can we make it turn into public good, right? That's, for example, also a use case of KYVE that's way beyond just the archiving of data, right? Also turning data into a public good, making it accessible, making data trustless, so I can safely use it between chains. Then with IBC, Accela, and so on, I mean, I can leverage tons of already trustless bridges to then get my data from A to B.
Yeah, so let's maybe talk about some of the use cases here. So I think one of the use cases that you mentioned in your blog post is these like archival nodes. So in Ethereum, you can have different types of nodes. One of those nodes is an archival node. It calculates all of the state transitions since the beginning of the chain. Those nodes are usually quite long to sync, can take like weeks, perhaps even like years at some point when the state becomes large enough. There are not a whole lot of people also have archival nodes, I think. Like, I think at some point it was estimated that maybe a handful of archival nodes existed. Maybe even the Ethereum Foundation didn't have one, or something like that. But yeah, but here with KYVE, we could say, okay, well, the archival data is available on KYVE. It's been proven valid, and so therefore, we could maybe forego having archival nodes, or this can kind of act as a source of truth, and you could do that for other blockchains as well. Is that kind of the value proposition here?
Yeah, you absolutely nailed it. It's basically about this like data accessibility and data validity, right? Because as I said earlier, there is no incentive for someone on Ethereum to run, like in ETH, of course, no incentive for ETH to run an archival node. I mean, I can sell it off to like analysts, for example, or projects that need to have access to archival data, and I can just charge fiat revenue on it. But there's no protocol-based incentive for that, right? And actually with KYVE, this idea switches, right? Because once data has been stored with KYVE, it's publicly and free available for everyone, right? Meaning there is no need anymore to even run your own archival node, because you can just get it from there. And we actually building out some super exciting tooling right now, which I think we will maybe release by the end of the month, that allows you to get your data from KYVE into any source destination you want, local database, Excel sheet if you want to, right? Or like your big Snowflake data warehouse. And I think that's also something we are kind of like actively pushing there, to then get rid of this problem of like archival nodes, and even node operators, right, can use this to sync their nodes even faster, because they don't have to worry about how do they get their data from this or that chain, really.
And so can you describe the architecture, like KYVE architecture? Like, what are the different layers here, and how do you leverage the Cosmos SDK? I think that's what people are really interested in.
Sure. So basically, it is actually a very easy concept if you really boil it down. So basically, we work with so-called storage pools. And storage pools, they run protocol nodes that are relaying data from A to B. So they're relaying data, for example, from Cosmos, right, or from Polkadot, whatever, over to Arweave. And then they are also validating this data. And the way it works is quite simple. Let's take Polkadot as an example. I pull down block number 5 from Polkadot and push it onto Arweave, and then tell the other nodes, hey nodes, this is my proposal of this data. Can you please check if it is correct? And then those nodes would go ahead, download this data from Arweave, and maybe pull down their local copy, check if it equals, and if it equals, it's fine. They vote with yes on this piece of data. If the majority has found yes, then the Cosmos chain picks this up and says, okay, developers, here is this bundle. This has been found valid. Or hey, here's this bundle has been found invalid, so please don't use it. And then, of course, we only store the valid one, so it makes more sense, right? So you get along this argument. That's a very fundamental process. And the incentivization behind this is that the storage pool requires funding. So you purchase KYVE token off the market, put them in the pool as funding, and then, that's amazing, perfect. And then the pool pays out the KYVE tokens to the validators as a reward for relaying this data. And then basically then the validators, well, they can have delegates, like a proof of stake system. But then basically that's the easy process, like a trickle down effect, right? The foundation might purchase KYVE tokens, put them in a pool as funding to make sure that they create a constant archive of the data. The tokens trickle down to the validators, and the validators might restake it for security or sell it off at the market. So it's a purely utility-driven token.
So we have funders. Who are these funders, practically speaking?
Usually, I would say foundations or projects that are dependent on the data. Easy example: if I'm, for example, the Graph. Let's take the Graph and Solana, right? The Solana, of course, has an interest in creating the archive of Solana for cost reasons on their end, and the Graph is maybe interested in ensuring access to Solana data because they might offer a product on top of this, right? Like the subgraph for Solana. And actually now it's cheaper for both of them to just fund the pool 50-50 and effectively split the costs, right? Than if someone would pay for that data. And then of course, a lot of people actually argue, well, isn't there a free rider problem? Because if I might be a small person, I don't have to pay. I can just benefit from the big fish, paying this. Yes, true. But on the other side, the big player will always make sure to refund the pool because they are building a very, very successful business model on top of this data, right? It's a bit like using a free version of a database online, and then you say, well, yeah, I don't ever have to pay for it. Well, yes, of course, because at some point you're going to scale, and then you want to make sure you don't put your customers at risk, right? So you start, of course, paying the database provider for providing a database. It's the same concept there. And because then a lot of people can split the costs, it saves a lot of money for everyone.
So we essentially have actors who are incentivized to have this data be stored permanently. The easiest go-to example here would be like a foundation or the team that is behind a project. They're incentivized for that data to be stored online. They would fund this pool. That pool can also be co-funded by several entities. The staking, those funds then go to, I guess here where I don't understand here is like, what's the role of the validators? So the validators, they are the ones who are verifying the data that's coming in, signing the data, attesting that that data is correct before it gets posted to Arweave. So the delegators, the validators get rewards. Who's paying Arweave?
Yeah, so the validators are paying Arweave, right?
The validators are paying Arweave.
So in a pool, we have, let's say, 50 validators, for example, right? And then we have this round system. So every round is one block, for example, right? So in one round, I might be the uploader. So I store the data onto Arweave, and I pay with this in R, right? And then because, well, if my data has been found valid from the others, then I get reimbursed in KYVE tokens, right? Which, of course, later on I can sell for the R I've paid now. And then in the next round, you might be the uploader, right? And then you do the thing. And then the next one, I am the uploader again. So it switches always from A to B. And the probability that I'm going to be the uploader is determined on my stake. So, of course, I'm always incentivized to have a high stake because I get a much higher reward if I have basically stored the data on Arweave.
And so the staking providers, the validators, they need to also take into account, like they need to also have R. They need to also be liquid in R. And there might also be some kind of treasury management there where they might be buying and selling R in order to maximize their return on their staking rewards. So there's probably like some game theory and economics going on here to maximize staking rewards versus like the amount of R they're spending.
Exactly. So you can do this, or either on the other side, Bundler offers a KYVE payment integration. So you can store your data through Bundler, and then you can just pay native KYVE. So you don't have to worry about that in theory. But something else, which is a very cool use case that KYVE can do as well. Let's say you're archiving a Web 2 API. Actually, for Say Network, we have this use case with sports betting data. And this costs you, of course, fiat money, right?
Yeah.
So what you do is you purchase your API key with fiat money, and then you just pull it into your node, and then your node uses this API key to relay the data. But then, of course, the node still gets reimbursed in KYVE tokens in order to pay for the API key. And every pool has its own parameters on operating and storage costs, right? Storage costs, depending on where they store the data, it's a factor of 1.5 on top of the Arweave price. So they get a 50% profit. And of course, the operating costs can be set also on a per pool basis. For example, if the API key is $100 a month, well, you can do the maths, right, to get a KYVE price that will reimburse people for that. And then through the governance, those parameters can be updated whenever.
Okay. So can you explain the process by which validators verify the data? So when let's say we're talking about a Web 2 API, because I think that's like a simple example. So you have an API for, I don't know, stock market prices, right? Like over time, and you want to have that data be in permanent storage. As a user of that data, what are the assurances that I have that the validators have come to consensus around this data? Are they all signing this data collectively? And is that how it works?
Yes, exactly. So to make this short, yes. So they vote on it. They're not signing the data. They are voting on it with a result either true or false, right? And the voting itself, like how you come to true or false, is completely up to the developer that is writing the implementation, right? So for example, for deterministic blockchain data, the proof is very simple: does the copy on Arweave equal my local copy? Yes, they equal. Okay, I'm going to vote with true, right? And then, for example, for pricing, like stock market pricing, there might be a little like slippage in the pricing, right? Because maybe in Frankfurt, the exchange rate is a different one than in New York. So actually in your validation function, you can just code in the slippage check and return, for example, true only if the slippage is less than 0.1%, for example. That's, I think, what Chainlink is doing. So it's completely up to the developers to customize this to their needs. They only have to return true or false at the end. That's the only thing that they have to do. And then, of course, the nodes, how you can make sure that the nodes vote correct is, first of all, they don't have an incentive to vote on the wrong side, like either invalid or valid, because then they don't get money for that because, well, they've been wrong, right? And of course, they have the stake as their security, meaning that if they voted on the incorrect side, their stake gets slashed. So they receive a slash for voting invalid or being offline. So you can make sure that there is this economic security from proof of stake behind the data that has been uploaded.
I'm trying to think as a Web 2 service. I think maybe like as a Web 3. So if you're the Ethereum Foundation and you want to store the entire state of Ethereum in KYVE, I think it makes sense to have a validator set that is verifying that data and posting it to the chain, because the Ethereum network can't sign data. We don't have the cryptography yet for a blockchain to hold its own keys to sign data. For something like, let's say, I don't know, like what one example, like a Bloomberg API or something, right? And like you want to store the stock market data into the chain. I could see where Bloomberg might just sign data and post it straight to Arweave. Like for Web 2 data, if you trust the signature of the issuer of the data, then you don't need KYVE. You can just go straight to Arweave, right?
Yes, exactly. So and I think this is now a bit of like this question on like how much security you want to have in a system, right? Where you can say, well, I'm already trusting the Bloomberg API on Web 2. So I'm just going to relay this one-to-one into Web 3, and then I'm going to use it there, right? You have kind of two, well, it's a perfectly fine solution, first of all, right? But you have one problem with it. First of all, something on the transport could go wrong, right? Which you don't know. And then how do you know later on if it's invalid? It's a bit of this redstone problem I talked about earlier, right? So like relaying the data immediately, but then later on, maybe if you already have the damage, you can say, yeah, but this was incorrect. And like, okay, cool. Like, sorry for that. But there's nothing that's going to happen. So that's one problem
No, but if the data is signed, and you have the signature over the data, are you talking about missing pieces of data or incorrect data? Because if the data is signed, there's no risk of this, right?
No, exactly. Well, if it's signed, then you just have to check the signature on your end, right?
Yeah,
it's actually correct, and then you would have to also copy the Bloomberg data down, right, in order to even create the other signature. Of course, that's a valid solution, but I think it gets especially interesting when talking about multiple data streams at the same time, right? Because if you want a system to be completely trustless on some data that can be trusted, right, like stock exchange data can be trusted if we go to multiple providers of the stock exchange data. And of course, then like the KYVE game comes more and more into play, where you say, okay, now we have to get multiple sources in, have to find consensus about this state. Actually.
Yeah, because I mean, if in any case where a sort of traditional centralized company wanted to have its data available on Arweave, they could just say, hey, here's our public key. We're signing that data. We're going to put it here for the benefit of everyone. They might have some economic layer in there where you have to pay for it or something. I don't know how that works, but let's just assume it wants to be, the data wants to be free. Then if you're using that data, then you're trusting the source. You assume you trust the source. Therefore, you can trust the signature. In this case, right? So let's say you had Bloomberg and maybe some other data that you wanted to aggregate. In this case where you mentioned, say, like, you want to have stock market data over time, but you want to do the average price across several exchanges or several sources of data, then that's where KYVE would come in handy, because you'd have the validator network that is sourcing that data, executing some sort of computation on the data, like an average of a price, putting that data in Arweave, and then signing it. But effectively, you have it's a new data set. It's not like a one-to-one data set. It is actually a new data set, and this is where
Exactly.
KYVE has like value.
Exactly, absolutely, right. And also you have to design your runtime implementation, of course, to solve this problem, right? On the other side, you can always argue, for example, with the Bloomberg thing, is it even in crypto mind to just relay data, like just have a one-on-one copy from a Web2, like from a trustful, like, just sounds so weird, but from a source that you would have to trust, like Bloomberg, for example, right? And then getting this data, right, into Arweave, and then do you trust Bloomberg? And then do you want to expose, especially in DeFi, right? Do you want to expose your users that are for sure thinking that your system is 100% trustless, right? We wanted to expose them to that risk. And our lead developer always likes to say, yeah, the only reason why we're making such an effort building blockchains and making everything trust is because we just expect one single person on this whole planet to fuck with the whole system, right?
Yeah.
And so I think it's really important that you then kind of like think about, okay, what are we optimizing for, right? Are we optimizing for true crypto? Then we cannot just relay data. Then we have to make it trustless.
Yeah, I mean, this I think like the philosophy. I agree with the philosophy here, where trusting single sources of data exposes you to risk, right? Like in this case, let's say that there were applications that were relying on this data, and someone malicious at Bloomberg wanted to provide some faulty data that would cause, say, like, I don't know, cascading liquidations or something like that. Like, I mean, you could do that. There might be some use cases where one would trust that data and would like be content with that, with trusting that data. But I agree that like we need sort of like resilient data that perhaps comes from multiple sources and has been aggregated, and where there are like mechanisms in place to fish out outliers and things like that. Yeah, no, this is really interesting. I really like this. So who decides basically, like, okay, in terms of public goods, right? So coming back to this Ethereum archival node idea, can the community kind of come together and say, like, hey, we're going to fund this thing because we think it's a public good and it should be available to everyone? Like, I noticed in the KYVE app, I think you guys are archiving like Bitcoin and Polkadot and Moonbeam and a bunch of other things. Like, who's funding those things? Especially like Bitcoin. Like, who's funding this Bitcoin archive?
So right now, but because it's testnet, it's like, I mean, we are funding this, right, with the ecosystem wallet. But actually, well, we have some measures in place for mainnet. It's actually that our first ever fundraise were just foundations from all the blockchains with convertible notes. So we had the Near Foundation, we had Solana, we had all the others, right? And so basically, it's like they have purchased these tokens early on to provide this funding for their communities, right? Then they kind of get the initial spark started, right? But of course, it's a completely permissionless system. So of course, if you have 3 people that have enough money and say, well, we would love to see Bitcoin being archived, they can of course get together and just turn it into a public good, right? Yeah, that works.
So for example, we had like the Bitcoin blockchain being archived. There's one person funding it.
Exactly. And actually, if you turn on the little expert mode in the upper right, for the audio only listeners, we're just exploring the KYVE webpage. And now I think you should see the funders if you scroll up there. Yeah, see there's no funders tab. The second one, if you scroll up a bit, there's no funders tab. Exactly. Okay. And then you can see who is funding the pool right now. So it's just the KYVE team wallet just funding that. Of course, in mainnet we have different things in play. And it's also a cool mechanism in my opinion, because it's a true validation on the business model. Because if you create a runtime and no one is interested in funding this, well, then there's also apparently no value in this data being stored right now, right? So why would you do this?
Yeah. And so as a validator, or as maybe not a validator, but as a,
we call them protocol nodes.
Right. Okay. So as a protocol node, if those protocol nodes also need to have clients for the chains they're storing in Arweave through KYVE. So if I'm, if we're backing up the Bitcoin blockchain, there has to be some client there that is relaying that information through KYVE.
Exactly. We're calling these clients, we call them runtimes. And I think if you would go back to the app now, you would see it's like every pool has like their own little runtime. Of course, all EVM-based chains are all using the EVM runtime. The Bitcoin is using the KYVE/Bitcoin runtime.
I see. Okay.
Exactly. And we made this as easy as possible for developers. So the core of the runtime is already written by KYVE, and it just exposes two functions. One is an upload data function, where you have to return some bytes. That's something a developer has to write. And the other function is the validate function. And the default one is does A equals B, but if you have a different one, well, you can override this function. And that's it. And then you publish this binary. And then the node runners have a pretty cool tool called Kysor, which is an homage to the Cosmovisor, which makes like running your KYVE node super easy. So you just point it to a pool, and the Kysor automatically downloads the right binaries and also automatically listens to updates in the governance and pulls the binaries in time so you don't miss the update.
Okay. Exactly. So I wanted to ask you about this. So for listeners, so Cosmovisor is a piece of software that is run by validators, and it essentially manages the binaries, right? Because like as a validator, you're running software on a machine, and whenever there's an upgrade, so let's say Cosmos Hub, Cosmos Hub binary Gaia D goes from version 1 to version 2. As a validator, you have to update that software, and Cosmovisor is sort of a wrapper that just allows you to put the software there, and then when the update happens, your validator automatically switches over. So it's kind of like it's a service that runs on your validator. How does this KYVE Cosmovisor what is it called? Kysor?
Kysor, exactly.
How does that work?
Kysor. Yeah. Exactly. It works it's the exact same idea behind it. The only cool thing is it actually supports listening to multiple pools at the same time, right? Because actually we are rolling out an update now. This is a complete alpha right now for I think everyone listening, for you as well. We're rolling out an update called interpool security, where now one validator is active in multiple pools at the same time. And then even, of course, Kysor makes even more sense because then the wrapper automatically listens to all updates happening on all pools, and then you can just have auto download enabled, and you're good to go and get never miss an update, so to say.
Okay, very interesting. Very, very interesting. And so as a validator on, say, Cosmos, if you're already validating the Cosmos chain, should you just start validating KYVE and like get rewards for, or like is KYVE as a validator node, are you dependent on running also a validator node on another network, or is it fetching the data through IBC?
Yes, so it is fetching the data by a foreign API endpoint, right? We're leveraging like POC network for that, Coinbase Cloud for that right now, Chainstack we are in contact with right now, right, for that. But of course you can plug in your own. So if you're already running, like to keep the story completely trustless, right? You're running your own RPC endpoint on Cosmos. You're going to archive Cosmos, just point it to your own node. Okay. That's what we want to trust.
So it's just, so KYVE is just connecting to an RPC endpoint.
Exactly.
Right? So you could connect to any public RPC endpoint, or if you're running your own validator, then you'd want to connect to your own public RPC endpoint.
Of course. And you can code this connection thing however you want, right? This is just how we as a team have implemented it. If we take the example, of course, of storing the sports betting data, right? You might work with one provider, and you, of course, write a function to just fetch from this one provider or from multiple. It's completely up to developers to code it.
Okay. Yeah. And so you're currently in incentivized testnet. How's that been going?
Crazy, honestly. that's a TLDR. It was crazy. We had I think so the incentivization phase ended a few weeks ago. We were like cleaning up the leaderboard and everything with 40,000 participants, which is insane. And participants really being like people that have like staked actively, right, claimed from the faucet and so on, and not people that have just created an address and sent some tokens, right? It's been absolutely mind-blowing experience from a growth perspective. It was a great stress test for the current architecture. It is running on the Corellia, is the name of the testnet, so that's running on the Corellia chain. I think the team learned a crazy lot of this. And yeah, it was very valuable for us, I must say. The contributions we got from a tech community and meme perspective were absolutely insane, really.
What was the biggest lesson from the incentivized testnet?
Good question. I think we had I think a good lesson for us was that we're actually capable of running this stuff under load and what like real load on the blockchain looks like, right? And then we were really able to optimize for that. So I think we're going to do one more big update now, and then we're actually done. Then we're like, it's going to be ready for mainnet then. I hope it stays with the one update. I'm pretty confident though, but it's tech. But exactly, so I'm really hoping that this kind of works out in the last update, and then I think then really good to go and give us a great UX insight into everything.
So yeah, what's like beyond the storing your favorite blockchain's data in Arweave? What are the other applications here? Like if you're thinking more long term and outside the box in terms of what this can be used for in the future, as Web3 grows and new sorts of businesses are built on using crypto and blockchains, what are some of the things that you'd be most excited about in terms of the use of KYVE?
Yeah, I think really that KYVE will become this like critical like middleware in your Web3 stack, right? Because it allows you to communicate, allows you to get the in communication from Web2 and other centralized Web3 data into a completely trustless Web3, right? And then utilizing some other tools like Acceler, like our new like Oracle module and stuff like this to then do the IBC to IBC transfer of data, right? Or of information. With Acceler, you even get it cross-chain and stuff like this. I said we're rolling out a tool by the end of the month that allows it to get it into your favorite Web2 stack. So like a whole new role for analysts there, right? And even like projects that might not work in Web3 but are interested in using Web3 data as like a no-code solution. It's one button and they have it in their favorite warehouse. Accounting is a very big piece where we see a big use case happening, right? That's a big thesis of mine. Now the bull market is over. Everyone's going to look back at compliance and accounting, and they obviously need archival history, right? Or history access to data. That's something I'm very bullish on. I think that's kind of the way we go and kind of like, increasing our market share there.
What's the roadmap? Like, when are you launching mainnet, and when can we start building on this?
Well, ASAP, I hope so. No, so we were planning to launch the mainnet in this quarter. We're just going through like the last stuff. We have one audit in place and stuff like this, and we hope that there's no major delay in that. But really looking forward, kind of like getting it out by the end of this year. And I think then we're ready to go from a tech side. It's already tested. The validation works, of course, from a mathematical point of view. There is no economic security behind it because we don't have a token. But that's like the big next thing on the roadmap, getting the mainnet out. And after that, it's a lot of, community and ecosystem building, I would say, right? Like use cases, pushing for use cases, granting out tooling around it, and so on and so on. At the road to decentralization after mainnet, I guess.
Wait, you said you don't have a token. There's a KYVE token, right?
Yeah, but it's not trading yet. That's what.
Okay.
Yeah,
I see what you're saying. Okay.
So in tested, of course, you can play around with it, but it's not trading.
Okay, interesting. Where can people learn more about KYVE? And I mean, what is your biggest ask to the community right now? Like, what do you need people to do, basically?
It would be way more like, finding use case, like not finding use case, but building out use cases on the tech side. I think this runtime development is a big thing. We will, as I said, push a new update there very soon. And then of course it's a burden on us, like, right, to create some better documentation around this, right, and get people on board. If you want to learn more about KYVE, like the docs are a good place to start. And then from there to the Discord, we have a very, very active Discord where you can ask a lot of questions and they usually always get answered. I would say that's from there. If you just want to check out some news, Twitter is a good place. I think we're tweeting around every day, every other day, maybe. It's always some very insightful content we're putting out there.
Cool. Well, this is really exciting. I'm hopeful to seeing, yeah, all kinds of new applications being built on this. And I mean, I think for me, the thing that feels cool about this is that it is, practical use case for Arweave. Not that there aren't any use cases on Arweave, but I think it's a use case that makes sense in the broader Web3 context, and could be a really good sort of like long-term incentive for Arweave to stay up and to remain permanent, as it claims to be, as it claims to do. Yeah, thanks so much, Fabian, for coming on. Look forward to
Thank you
chatting
so much
again.
for joining me. I really enjoyed it.
Thank you.